All right, new day and another laptop that needs to be saved, and this time we have an Alienware M16R1. This is a 16-inch gaming laptop. This laptop was sent in to me because the customer said that they accidentally unplugged the charger while charging the battery, and now it no longer charges. They tried 4 different chargers, they tried different batteries. They're hoping that we can fix this. They spent a lot of money and they got nowhere, so I haven't taken a look at this yet. Let's take a look together and see if we can get this figured out. All right, so the first things first, let's see if it turns on. The note says it actually would turn on a charged battery, but it will not charge off of a charger. Now, the note said they accidentally unplugged the charger while it was charging, and that's what damage is. That's not what will cause that type of damage. So it must have been a fluke. I don't really know what's happening. So let's plug in my charger and see what it does. I see that's pulling 0.08 amps, 0.09. So we're right around 80 or 90 milliamps. Let's open a lid and see if that changes. It does not change. Now let's push the power button. And it went up to 100 milliamps, but that's it. So nothing's happening. But they are saying that if I had a charged battery, that I could get this thing to power up, and eventually it would just kind of deplete and go down. So for some reason, the charger is not working. Let's open up the bottom and let's take a look inside. All right, and the bottom is off. All right, so let's take a look. What I see here is we do have an aftermarket battery here. You can see the label looks completely fake. Doesn't look like a Dell battery at all. And you should have a serial number here. He did include his original battery, so we do have that. And I will probably test it with this. But we have both of them here. We have some Fury RAM installed in this one. And here's where the DC jack plugs in. And it is plugged in all the way. Unfortunately, on this particular machine, I can't measure at all the MOSFETs right here on this side of the board. It's actually on the other side of the board, but we can measure coming out of the DC jack to see the voltage going in there. So let's go ahead and do that while we have it open. So let's get under the microscope. All right, so here's where the DC jack plugs in. Yeah, it was plugged in all the way. Sometimes I've seen it look like it's plugged in all the way, but it's not. And let's just measure the voltage coming out of here. So this side should be the, oh wait. Let's plug in the power. Now we should get our 20 volts. And we are getting our 20 volts to these pins right here. Should be this one, this one, this one, this one, this, all these. And then these are going to be the ground, and then that should be the PSID pin that detects what wattage the charger is. And so that might be what's going on here. So we could have some sort of charger detection issue. We are getting the 20 volts here, but unfortunately I will have to pull the motherboard out so we can take measurements from the other side of the board. So let me go ahead and do that. All right, before we pull the board out, actually, let's measure how much voltage we have at the battery. I want to see how charged up it is. It says the battery has 0 volts. That doesn't necessarily mean the battery has 0 volts, but it may be shut off. So let's pull this battery out. I'm gonna put one of my test batteries in here that I know has a charge on it, and that will make it a little bit easier to test. I don't like aftermarket batteries anyway. I know that they are cheap, but they are not reliable. All right, the battery is out, and I'm just gonna look at the cable real quick. This cable plugs in the back of the battery, and I don't know if it was plugged in all the way, but we're gonna plug it into my test battery. This should have a charge on it. All right, now let's measure to see what voltage we're getting. All right, now we have 10.9 volts. So it's not all the way charged up. It's about 20% charged. Let's see if the machine will power on. Okay, I am getting the keyboard backlight and the Alienware head is lighting up. I'm gonna plug in the charger while we're at it just to see if it will pick up that battery and start charging. And look at that, we do have 2.89 amps. Huh, okay. Does that mean that that aftermarket battery was no good? So we are pulling full charger amps. So I'm not sure exactly what's going on at this point. We're just gonna have to see if it posts, and then we'll play around with seeing if it's detected properly or not. He could have just had a battery failure or something like that, but he's had different chargers. This machine doesn't need a battery to actually run, but if he is plugging one of these aftermarket batteries in and it's not connected properly or it's not working right, then he'll have an issue with the machine. We're gonna let this boot up and then we'll be able to test. After letting it sit for about 5 minutes, I finally got the Alienware screen and now it actually did post. So let's go into the diagnostics. I wanna see what's going on. I could tell something weird is happening here because the system should be pulling a little bit more current than 93 watts, especially if it's trying to charge the battery at the same time. So let me cancel out of this. We're gonna get to our screen where it shows us the info about our battery. 52% charged, excellent health, and it shows it's actually discharging from the battery right now. And it's saying no AC adapters detected. So it doesn't detect that the AC adapter is plugged in. I do have one plugged in here. This is with with the customer's charger. So let's switch out to my charger. And on my power meter here, you can just plug in the customer's charger in the back of the power meter. I'll just plug mine in there. Mine's at 240 watts, so let's see what that does. It's still not detected. So the way that these chargers work is you have positive and you have negative. That's going to be the main 20 volts. And then you have a communication line, the PSID. And that is what's going to talk to the laptop and let it know what type of charger you have. If it can't detect a charger, then it will run it either in like a safe mode almost, or this machine won't even host a lot of times if you don't have a high enough wattage adapter, or it needs the battery to help it turn on. So if this can't detect the charger, then it's going to probably clock the CPU down to like 700 megahertz or something like that. I suspect that's the reason why it took so long for it to post, is because it was trying to start the machine, but it didn't know what charger it was. So we're going to have to try to pull this board out, and we're going to see if we can follow and figure out, there must be a burned component on the PSID pin. And once we get that fixed, hopefully that will fix this showing up here. We could also try a different DC jack. Maybe we should do that before we pull the whole board out. Yeah, let me do that. All right, got a new DC jack, and it'd be great if the issue is just simply that it cannot detect the charger because the DC jack is no good. So I'm just gonna keep the machine on because I'm crazy. And it's running on battery right now. Oh, the fan got me. It's running on battery right now. I'm gonna plug in the new DC jack. I don't wanna unplug this because it took forever for it to post. So, and then now we'll plug this back in. And we want to see if it's going to pull more amps than just that 4.59. I don't see it doing that. And then we can go back to our diag screen and see if it's still pulling current from the battery itself. And it is. So the machine's still running off the charger, basically, but it's discharging the battery by 23 milliamps because the charger's still not detected. So we are going to have to pull this board out, so let me go ahead and do that. I was hoping it was going to be something simple, but it's not. But I know that this customer has spent a lot of time buying different parts trying to fix this. So I was assuming that they'd already tried the new DC jack. I don't know if they had that in the notes, but I always like to try my own stuff. So we've tried my own battery and DC jack and charger. So we can rule that out. So we know that it is definitely a motherboard issue. All right, I love the way that this machine's built. I mean, look at this whole thing is basically just a heat sink. It has two fans on the CPU side and one fan on the GPU side, but it is cooling the chipset, it's cooling all the other components, the power supplies and things like that. But we will need to take this heat sink off. There is liquid metal underneath here. We're just gonna leave that intact. We'll move it out of the way and we won't mess with it, and see if we can follow the trail of the PSID pin and figure out where it goes, because I'm not 100% sure where it goes. And we can actually measure right here to start and make sure we don't have a short on the PSID pin. So these are all ground, and then this end pin is gonna be the PSID pin, and we're measuring 39 kilo ohms, so not shorted. We know that's fine. Actually, let's plug in the charger and see what voltage we should be getting, somewhere around 3.3 volts. I think on this system, actually, it's like 0.8 or something crazy like that. Okay, so we're gonna measure this while we plug it in, and 3.1. So, I mean, that seems within range to me, but it definitely isn't detecting. So we need to figure out where this is going. We need to make sure we don't have any blown components or anything like that. It's definitely going to the other side of the board because we have a bunch of vias here. And so all this stuff's going to the other side of the board. So let me see if we can track that down. All right, so from what I can tell, it's coming over here somewhere. Let me take this board off, this daughter board off, and just get that out of the way. It's gonna be one of these components over here. I think these are diodes. I see something burned. Right there. Right there. Do you see it? All right, we definitely got lucky on this, or he got lucky. So I knew that the charge circuit was over here somewhere, and I knew that the PSID circuitry should be over here somewhere. And I think this is the power management controller chip, because a lot of times that's what's actually in charge of turning on and off the MOSFETs to handle the charging. And so that makes sense that that got burned. But let me pull this heatsink off because I cannot see exactly what chip it is. So like I said, there's gonna be liquid metal in this. We're gonna be very careful, and I'll just try to leave it in place. This guy has a 4090 in here, I think, so we're gonna, we wanna keep the cooling on as much as possible. And if we need to, we'll put PTM 7950 on there, but I'll just try to keep this in place. And if you watch my other videos, I do not like liquid metal at all, so maybe I'll give him the choice. It's dangerous stuff, leaks everywhere. All right, let's lift this off carefully. And it looks like the CPU and GPU have liquid metal on it. And it's perfectly in the middle, just where it's supposed to be, perfectly in the middle. So I don't see an issue with this setup with liquid metal, so I'm perfectly happy with leaving it. But let's take a look at what we got burned. And it is the power management controller chip. Yay! Okay, so hopefully this is going to be a pretty straightforward repair. So 95522AH. I don't know if I have any of those though. That's the problem. Let me see if I have any that we can just swap out. Otherwise I'll have to grab a donor board. Let me take a look. All right, I don't have any of these chips in my chip inventory here. And I looked and I can order, there's a version of this 95522AH that doesn't have a letter at the end. It's supposed to be, let's see, let me pull this up. So Mouser does have these chips. They have these in stock. I can order these, but I'll have to order a whole reel of 6,000 of them if I go this route. I have a donor board. I'm just going to pull the chip off the donor board for right now, and that way we can get this customer working again. All right, I found a donor board with the same chip, so we're just going to take it off of there. This is a different version of Alienware, but it has the same power management chip, so we're going to use that. I don't know what happened, but the footage got messed up, but I pulled this chip off this donor board and transferred it over. It is the same chip number as the original one, but sorry about the lost footage there. But here's a good test. Let's see if it actually starts powering on, because you remember that the board actually wouldn't power on when we were testing it earlier off the charger. Where's my test adapter? So we're going to plug in this DC jack, and this is just a good test to see, did it resolve the issue, right? So if we plug in the charger, keep an eye on the power meter right here, we should start getting more than 0.08, because that's what it was doing earlier. We are pulling, like, 2 amps. So that means that the charger is now detected and it will start to actually boot the machine. So let me get this reassembled and then we'll continue testing. All right, I got the motherboard installed. I went ahead and installed their original Dell OEM battery instead of installing this aftermarket battery, because the question is going to be is why did that chip blow up? He said he thought it was because he unplugged the charger while it was charging. That does not happen. But I've seen those things blow up because you have aftermarket batteries plugged in, or you have aftermarket chargers plugged in. So if you're using anything that's non-Dell genuine, that's what blew out that chip, not you doing something that's, you know, not normal. Like unplugging the charger is fine. Don't worry about that. So let's see if this thing turns on. I have his original battery in here. I don't know if he replaced it after it happened or before it happened or what, but we're looking at the power meter, 0.67, 2 amps, got it, baby. Look at that. Keyboard's lighting up. Now, last time I turned this thing on, it took more than 5 minutes. I cut it out, I just jumped to it, but it was more than 5 minutes of sitting here and waiting for the screen to come up. Now, the only reason why that would be happening is if it didn't detect the AC adapter and it was running at like 300 megahertz. And so it does everything super slow because it thinks you have like a 40-watt charger plugged into this machine. And so it has to be very careful with how much current it pulls. So at this point, we have my regular 240-watt charger plugged in. His 330 is wired over here. I can plug it in at any point, but right now we're just going to start with my 240 because I know that's functioning. And I need to make sure that what he sent in is an OEM charger too. I want to make sure it's a Dell genuine and not a aftermarket charger. So let me check that. Yeah, so the charger that he sent in here is a OEM. It says Dell on it, has a 330 watt, and it has that serial number and the barcode. So that's what we look for whenever we're trying to figure out if something is authentic. Now, they do have knockoffs that are, you know, emulating all that. I can still tell the font's a little different, things like that, but we're gonna let this sit here for a second. Okay, the machine turned off, that's good. So it went through it's doing a lot of checking screens, checking memory, checking CPU, things like that, and then it should turn on and off a couple times, and then we should get our Dell screen. All right, we got our Alienware screen, that's good news. Didn't take 5 minutes, that's nice. It does say I have a lower watt charger than it recommends, so let's see if we can, oh, we're pulling 9 amps now. We weren't doing that before. I'm gonna unplug it real quick and just move to the 330. Ooh, it died. I unplugged it because I wanted to put their 330 on there, and now we have to go through a CMOS reset again, maybe. Let's see. But it was pulling 9 amps, that's good news, because it was actually pulling more than it was doing before. All right, I got it booted back up with their 330 plugged in, and we're not getting that error anymore saying it's an underwatt charger, so that's perfect. Date and time's not set because it was just a CMOS reset. We're gonna go straight into the diagnostics, and we will go straight to the charge screen. I wanna see what current we're getting in. I can see that we're pulling 192 watts out of the charger, saying the battery's not installed at all. So this is just running the laptop altogether, 190 watts. CPU's hot. It's at 95C, so we're gonna have to deal with that. I guess we'll have to switch out the battery, and then we'll continue. Look, I didn't even have his battery plugged in for some reason. So let me plug the battery in, and we'll try this all over again. All right, I went to the BIOS first. You can see the battery is installed, it's charging, it's in excellent health. The AC adapter is detected at 330. Let's boot into the diagnostics now. So I'm just gonna hold down the FN key when I hit the power button. That will boot us straight into diagnostics. The other option on a Dell would be to hit F12, and F12 would take you to a boot menu, and then you can just choose to boot into diagnostics. Okay, so battery is detected now, and we're showing that we have current flow into the battery is 0. This could be because the battery is below voltage, and so it may take a little while to trickle charge it back up to a appropriate voltage, because I can see the battery is at 8.5 volts. So if we can get this battery voltage back up to above 9, then it should charge at normal voltage, and it may try to, it has to kind of pulse it occasionally, so we're gonna let it sit here and do that. And it looks like the CPU is actually staying at the right temperature now. I realized later that I had it sitting on the desk and there was no airflow. And so I actually have it propped up now so the air can actually flow. It is at 85C, which isn't that good. So I think I still want to put some PTM 7950 on it, but I'll talk to the customer about removing that liquid metal or not. All right, it's gonna take a while. Let me plug our test battery in here. That way we can at least see something charging, because we wanna see some current. Or we can put I guess we can put that battery in there. I don't like aftermarket batteries, especially if it blew it out. I'll have to ask him when it blew out. Was it after he'd put that in, or was it before? All right, we have our test battery. And we will be able to see it just by looking. So I have the machine still on, it's at pulling 200 watts, but when I plug in this battery, we should see it start pulling some more current. So it dropped down to 158 watts, and it should jump back up. Why did the watts drop when I plugged in the battery? Okay, battery flow. It's saying it's pulling power out of the battery now. So it was just running off the charger, and now again, it's pulling power out of the battery. So did we resolve the issue? I'm gonna unplug the charger. Okay, it's running off of our battery. 8 amps pulling out of the battery, 6 amps. So now I'm gonna plug it back in, and the machine shut off. It shorted out the AC adapter too. That is not good. So we have something conflicting in that area, and I'm wondering if we blew out that power management chip all over again. So I'm wondering if this is the same scenario that he went through when this happened. So let me plug my charger back in. Let's see if it still shorts out the AC adapter. So I have our test battery plugged in. Actually, I'm gonna unplug our test battery. Let's do it without that. Let's see if it shorts out again. It is. So now it is shorting the charger every single time. So what that means is we probably have some sort of MOSFET that got shorted, or something else that's what was causing the initial issue, and maybe it was like halfway triggering that ended up burning out the power management chip. And so this could be actually a good thing, because I've seen this in the past where when we have something that's intermittent or it hasn't revealed itself all the way, now it just revealed itself. And so we should be able to figure out what is shorted, get that replaced, and then if it damages the power management chip again, we'll replace that, and then we should be good to go. So pull the board back out. All right, we got the motherboard pulled out for, I don't know, second time, third time. And now we get to figure out what is shorting out the board. So when it's shorting out, whenever you plug in the charger, it's most likely going to be on the main power rail, and it's instantaneous too, right when you plug it in. It's not like it's delayed. So we need to figure out what on the main power rail would be shorting out. I hope it's not like a CPU or GPU issue. That'd be crazy if we have that. It doesn't make sense that that would happen now when it wasn't happening before. All right, heatsink is off. All right, let's take a look over here in this area. So the power management chip is fine. It's not burned up, which is good news. But I'm gonna put our meter in continuity mode where the probes will beep if you touch them together. And we're gonna put one side on ground, and we're just gonna kind of probe around and see if we measure anything shorted. Well, here we go. This current sense resistor is shorted. Now, it may be one of these MOSFETs that are on the charge circuit that's causing this. Maybe a low side. These do look a little bit shiny, but this may be from the thermal pads. Sometimes they ooze out a little bit of oil. Let's see. This current sense resistor is measuring 0 also. Yeah, this is almost like a MOSFET's shorted, like on the low side MOSFET shorted, is what it seems like. That one's shorted also. So we'll have to get our thermal camera out because I don't think we're gonna see what the issue is. All right, so let me go ahead and get the thermal camera set up. All right, got the thermal camera set up. We're gonna inject, since it is almost 0, we're gonna go down to like 0.5. So I'll put one side on ground, and then we will inject right on this current sense resistor. Where'd it go? We can do this one right here. So keep an eye out. The board is still a little warm, so hopefully you'll be able to see it. And 5 amps. And what was getting hot? Yep, it was one of those MOSFETs. It's one of these two that we were looking at. Look at this. Look at that, you see that? And I think it's the one, I mean, I would think it's gonna be the low side, so the side that goes to ground. So I'm just gonna put some alcohol on here to identify which one it is. It's not getting super hot, whatever it is. Let me make sure it's nothing on the other side of the board. In the other side of the board, we don't really have anything besides some of these capacitors over here. Let's see if these are shorted. So none of these are shorted out, so it's not going to be one of those. So it's probably one of those MOSFETs. I'm not sure which one it is. I do believe it's this one, if we look closely. Yeah, looks like it's this one. And if we measure there, well, this one's measured shorted also. That's interesting. So these are both measuring shorted. All of this is measuring shorted. That's interesting. Do you think that the power management chip's actually telling it to stay on? Let's see if the gates are shorted. That's showing shorted. What about this? Yep. Let me remove just this one, and then we'll take a look. It would make sense if this MOSFET was failing that this chip would have blown out. So let's pull that one off and see if that resolves the short. All right, I got it off of there. Let's test it and see if it actually had resolved the short. And we can actually measure this one and see if this one's actually good too. And the short is gone. Okay, so now let me show you how we test MOSFETs. Because there is a chance that the power management chip's actually telling this thing to turn on or being stuck on. So let me show you how we test this. So we're gonna put our meter in diode mode. And we have 4 pins coming in and 3 pins going out, and then we have a gate pin that turns it on and off. So these 3 pins are going to be tied together, and you see how it's saying it's just shorted. But if I touch here, it's shorted also. Yeah, these are all shorted. Now these should be independent. They should not be connecting together. So if it was actually functioning properly, I should be able to do reverse voltage on this pin, and then it would turn this off, so the gate would actually trigger, and then it could do this voltage on here and it turn that on. So this one's definitely bad. It's shorted all the way around. Let's see which chip it is. B04N03R. I have some of those. So let's grab a new one of these and get that installed. All right, to figure out which way this one goes, I just look at the bottom, and you can see that the 4 independent pads are going to be on that side, so it's going to go that direction. All right, there we go. Let's get this cleaned up a little bit. Clean up my mess. I gotta clean up after myself. We want no evidence that anything has been done. Okay, let's see if the short is gone. The short should be gone. Short is gone. Diode mode is detecting properly. And that looks fine. It's just I had to fill up a capacitor. Okay, so let's do this again. All right, I got the motherboard installed all over again. I have his Dell battery in there because I'm determined to get his Dell battery working. And let's plug in the charger. It did not short the charger now. The machine is coming on. So we keep having different issues, but they all kind of correlate to the same thing. Now, the way that the charge circuit works is you have a high side MOSFET and a low side MOSFET, and then a coil right in the middle, and that's what's actually reducing the 20 volts from the charger down to the 12.6 that the battery needs. Well, the low side MOSFET ended up shorting to ground because that actually attaches to ground, and it got stuck on. So all the voltage was just going straight to ground over and over again. That's why we kept showing a short everywhere in that area. Now that definitely could have caused an issue with the power management chip in the first place. I don't think it went the other way around, but plugging aftermarket batteries in there could cause that issue too. So we don't know exactly what caused this yet, but hopefully we resolved the issue. So let's get this booted up in the Diag so we can test. All right, before I boot this up, I actually want to make sure that we're not having an issue because remember we have the high side and the low side and that was shorted the ground, so we replaced that one. But originally we were measuring the top one shorted too, but there's not a short to ground. But I have the charger plugged in right here, and let's measure the battery voltage on the battery connector, which should be 12.6 volts or off, you know, because I don't have a battery plugged into it. And we're measuring 19.8, which means that we're getting charger voltage to the battery connector. And I wouldn't want to plug a battery into that because that will end up shorting out the board too. So I think what we have happening is both of those MOSFETs are bad. So I'm going to end up having to replace both of those MOSFETs to resolve this issue, but it is getting late, so I'm going to do that in the morning. So it's the next day. It was getting late last night. Let me go ahead and pull this board back out. All right, we got the board pulled back out again. Now I'm going to have to pull the heatsink back off again, but you know, the main thing that we're looking at here is, you remember those two MOSFETs? We were talking about the high side and the low side. We changed out the low side because it was shorted, and I just guess I wasn't thinking straight last night, but the high side had to have been shorted too because the power from the charger was shorting to ground, and the only way that would happen is if both of those were shorted. Now, I think I wasn't thinking that they would both be shorted because that's not really a common thing that happens, but one of those must have been failing and then caused the other one to fail, or the power management chip which controls those is the culprit that caused all this damage anyway. But once we get that MOSFET changed out, it should resolve all the issues. I have seen this in the past. Usually, whenever we are measuring 19 volts or 20 volts at the battery connector, it definitely points to that MOSFET being shorted out. Now, whenever we use the term shorted, a lot of people will think it's shorted to ground, but that's not what we're talking about. We're just talking about something stuck on. So if you think about the MOSFET as being like a switch where it's on or off, well, the MOSFET's stuck so it's shorted on, so basically all the voltage is going right through it. So if we take a look at our MOSFETs that we were working on yesterday, so we have charger voltage is going to come through here, and then this gate pin is going to be pulsing. Where's the gate pin at? This gate pin right here is going to be pulsing, and to reduce the voltage from the 20 volts coming into this down to 12.6 for the battery charger, and then this goes to ground on this side. So it comes through right here. This side's actually connecting to the battery connector, and we have a current sense resistor to tell how much current is going into the battery. So right now, I guarantee that this is shorted out. This one we did replace, and so we can verify that. So we have our meter in continuity mode. So if I measure across here, this should be measuring nothing. And then if we measure across the gate and the output, that should be fine. But this is the one that I'm thinking I'm shorted, and it is. So the charger voltage is coming right through this MOSFET and coming straight to this coil, so we're getting full 20 volts here. And let's check the gate pin. And you can see this is the gate pin, and this is the output. And if we measure that, that's shorted too. So this entire MOSFET is shorted. I should have thought about this yesterday. You know, that's what happens when you have brain fog from having a long shift. So we'll put a brand new MOSFET here too, and that way we have a brand new pair, and that should resolve all of our issues. So let's get this chip pulled off. Okay, we got that one off. Just gonna straighten this one up a little bit. There we go. All right, so let's grab a new one. All right, so here's our new MOSFET, and it's gonna go this direction right here. Let me put a little flux down. Okay, perfect. Okay, so we got them both replaced. Before we reassemble, I'll go ahead and test that area. We want to make sure we have the right voltages there. We'll go ahead and see if we can charge the battery with it off. The problem with this machine is whenever we plug in the charger, it's going to want to power on automatically, so it's kind of hard to test whether it will charge with having the machine off. So we'll do our best to see if we can test that. So let's clean up our mess, and then we will do that test. Okay, that should be cleaned up enough. All right, so I'm gonna put our probe on the output here. This is the charge coil. I'm gonna put our probe right here on the charge coil, and we don't have a short. We could actually measure across that MOSFET too, just to check that. And we don't have a short across that either. All right, let me put our DC jack on here. All right, I have it in voltage mode. I have my probe on the charge MOSFET output, and then we're gonna plug in the charger. I just wanna make sure we have 12.6 going there. And we have 1.2, but we are pulling full voltage. So 1.2 is low, but that's because the battery's not connected. Let me grab a battery. Actually, let's just go ahead and reassemble it. We know what we didn't want to see was the 20 volts going straight there. This thing usually won't turn on the charger voltage unless it detects the battery, so that is correct, that what we were seeing anyway. So let me put the heatsink back on and we will get this reassembled. All right, I got the motherboard installed, and I put the original Dell OEM battery in here because I want to see if this thing is functioning. I don't really want to put that aftermarket in there. But let's plug in the charger, keep an eye on the power meter. And let's see. Okay, it's not pulling any current. It should turn on automatically. Okay, when I opened the lid, it turned on. So it's pulling 3 amps, 60 watts. And we're gonna have a CMOS reset process, so let me get it in the diag so we can test. Actually, I realized it was pulling 60 watts and the machine actually wasn't even on. It was charging the battery at 60 watts. Now I turned it on and now it's pulling 126 watts. That is something new. That's exactly what we're looking for. We're looking for it when it's turning on, it's pulling 60 watts for its first CMOS reset, and then it should jump up to about 190 watts or so, and then the battery charges around 60 watts. So this is a good sign. So let's get it in the diags and so we can actually see if we have current flow into the battery now. All right, let's get in the diags. And I can already see that we have a different current rating here. This is exactly what we're looking for, is that it's showing that it's pulling some more current than normal. And look at that. It is showing that it's charging at over 5 amps, which is perfect. Let's make sure it runs off the battery. So I'm gonna unplug the power meter. And now it's running on battery, pulling 6.2 amps out. And then we'll plug it back in. I just want to make sure that we'll switch between the two. And it detects the charger, it's idle, it takes a second before it switches back to charging. And perfect. So we do have 5 amps going back in the battery. So I'm speculating that he had a charging issue and then replaced the battery, or he bought another battery because he wanted one that had a newer life on it or something like that. So I'm gonna call him and figure that out. But the good news is we were able to resolve the issue, and I'd love to know your thoughts on it, and thanks for watching.
I saved another laptop.